So in this one, we will see how to calculate the maturity value, or future value. So if you are investing $1,000 for 200 days, so the amount what you will receive after 200 days is the maturity value or future value. So the amount you will receive is that $1,000 plus the interest what you earned in these 200 days. So let's see an example. So on August 3, 2019, Red Flag Inn invested $28,900 in short-term investment that matures on March 6, 2020. An investment of this length earns 1.3% per annum. How much will the investment be worth at maturity? That is, what is the future value of the investment? So we have the principal amount as $28,900 and rate as 1.3%. So we can write the principal amount as 28,900 and your rate is 0.013. That is converting the decimal from percentage. And then time you have August 3 to March 6. So we need to count the number of days. So August 3 to March 6. So August 3 to March 6. Here we need to leave the first one, excluding the first 3 days. So that is 28 days in August, September, October, November, December, January, and February 2020 is leap year. So 29 days in February and March 31 days. So we will add the number of days and you will see the total number of days is 216. And writing this in the formula, so that is S is equal to P1 plus RT, and we will substitute the value P is 28,900 and 1 plus R is 0.013 and time is 216 over 365. So while calculating, you will calculate this in using the BEDMAS rule. So that is, first you will multiply and divide and then add 1 to it. So that means you will calculate the bracket first and then you will multiply it with 28,900. 0.013 and then multiplied it with 216 and then divided it with 365. So you get this value and add it to 1. So you get the bracket value and multiplying it with 28,900. So you will get this value. So taking till to decimal place, you have this answer. So we are considering all the decimal places. We are not truncating any of the values till to decimal place, so that your final answer will be exactly till to decimal place. Correct. So you will see here the same answer what you got it there in your calculator. So let's see another example. Find the maturity value of a deposit of $1,250 invested at 2.75% per annum from October 15, 2017 to May 1st, 2018. So 1250 is your principal amount, 2.75% is your rate, and you will see here principal amount rate, and if you count the number of days from October 15 to May 1st, so let's see the counting here. So October 15 to May 1st. So October there is 15 days over, so remaining 16 days in October, November, December, January, and then February, because 2018 is not a leap year, so it is 28 days in February, March, April, and May 1st. So if you add all these, so you should get 198 days. So total 198 days, and if you convert it into years, so 198 over 365. Substituting in the formula and then calculating the same way following the BEDMAS rule, you should get $1268.65. So now we'll see how to calculate the principal value. So the principal amount, that means how much you should invest today so that you get $1,000 after 200 days, right? So it can be investment amount or how much loan you have taken so that you need to return back $1,000 after 200 days. So you have to find the present value or the principal amount, investment amount or the loan amount. So let's see an example. So compute the value of an investment 8 months before the maturity date that earns interest at 6% per annum and has a maturity value of 884. So here the maturity value, that is S, is 884, R is 6%, that is per annum rate, and time is 8 months. So if you see here 884 as your S, 884, and your R is 0.06 and time is 8 months, so which is 8 over 12. So if you substitute in your formula, so 884 over 1 plus RT, which is 0.06 times 8 over 12. Right, so while calculating the whole denominator, you need to calculate it together and make sure if you are calculating separately the denominator, you should consider it to 6 decimal place and then divide it. If you are calculating all it together, so make sure you are putting bracket for the denominator. So let's see the calculation in the calculator. So we have 884 as your maturity value, and then divided by, you will enter a bracket and then 1 plus 0.06 and then times 8 divided by 12. So I wrote the complete denominator inside a bracket, and then if you calculate, so you will get the correct value. So you can see that you will get the same value as what you got it in calculator. Okay, so the next example, so what sum of money must have been invested on January 31st, 2016 to amount to $7,500 on August 18, 2016 at 5% per annum. So I would like all of you to pause your video and try to do this problem your own. So you need to count the number of days from January 31st to August 18. All of you know how to calculate. I can give you the hint that 2016 is a leap year. And then maturity value is $7,500. R is your 5%. Substitute in the formula and use your calculator to calculate. So after calculation, you should get the number of days as $200 and principal amount is $7,300. So check if you're not getting, just let me know and we can discuss it later. Okay. Next is equivalent value. So equivalent value is an application of future value and present value. So money in different time frames have different value. So $500 today will not have the same value in future. So you know that interest will be included in that. So it will not have the same value after 200 days. And the $500 today will not have the same value 200 days ago because you will subtract the interest in that. So that's how we calculate the present value. So this is an application of present value and future value. So the formula what we will use here is present value and future value. Let's see then example. So a debt can be paid off by payments of $872 1 year from now and $1,180 2 years from now. Determine the single payment to now that would fully repay the debt. Allow for simple interest at 9% per annum. So you have to return $872. What will be the value of $872 in today's time? That is 1 year back. Or if you need to return $1,180 after 2 years, what value of this one will be 2 years back? Or how much loan you have taken in today's time so that you need to return after 1 year $872 and $1,180 after 2 years. Right, so we will here find the present value to calculate the amount of 872 1 year back and $1,180  2 years back. We need to find the present value of 872 and present value of 1,180. So we'll use the formula P is equal to S over 1 plus RT, where S is your 872 and 1,180, R is same, that is 9%, and T is 1 year for this, 1 year or 2 years for E2. So we use the formula here, this one, so this is E1, 872 divided by 1 plus R times T because it is 1 year, and this is your 1,180 divided by 1 plus R. R is 0.09 and T is 2 years. You can calculate what is E1 and E2, add these two to find the single payment which should be paid today so that you can clear your debts. Okay, so let's see the another example. So two amounts owing from the past were to be paid today. One debt was $620 from 1 year ago, and the other was $925 from 6 months ago. Determine the single payments today that would fully repay the debts. Allow for simple interest at 12% per annum. So $620 you have taken a debt 1 year ago. So you will find, so if you have taken $620  1 year ago, so how much you need to return in today's time? So you will return 620 plus the interest for this 1 year. So you will find E2 as a future value of $620. And the same thing for $925, that if you have taken $925 6 months ago, so you will return 925 plus the interest for this 6 months. That is future value of $925 will be your E1. So we'll use a future value formula for E1 and E2, that is P1 plus RT, where P is 620 for E2 and 925 for E1. R is 12%, and T is 1 year for E2 and 6 months for E1. So if you see, so 6 months, we can convert it into number of years, that is 6 over 12, and we substituted in the formula of future value for E1 and E2. You can calculate using the calculator what is the value of E1 and E2. Add these two to find the single payment which you can return it today to clear up your debt. So this completes all the topics of the simple interest. In the next one, we will see how to calculate the compound interest.